Welcome to lesson 2 of unit 12. Today we're going to use combinations to count the number of ways an event can occur. So yesterday we talked about what was called a permutation. This is an arrangement. So if you think of the word permutation, that's an arrangement. And in an arrangement, the order matters. Because if I arrange things in a certain way, the order is important because if I order it differently, then the arrangement looks different. Okay, order matters. An example of a permutation would be a race. And order matters. You have first place, second place, third, and so on. The order matters because if you're in a different place, you get a different prize or different recognition. Now, today we're going to talk about another type of basically way to arrange things, but in this case, in combinations, the order does not matter. So I use the word blend for combinations because order does not matter. Doesn't matter. I use the word blend because a blender is a great example of a combination. If I have a blender full of stuff, right? Let's say you have a blender at home and you have a little mixer and they have the buttons up here, right? And I need to throw all my fruit inside of this blender and I turn it on and it just starts going and blends everything together. Once I get my smoothie, I don't really know what order things are put in because it's all blended together. So that's an example. An example would be a smoothie for a combination because order doesn't matter. Or another example that's not food related might be you have a committee, but everybody on the committee has equal standing, so it doesn't matter what order you pick people. It's sort of like when you pick on a basketball team. If you're picking a basketball team, the order doesn't matter. Everybody's still on the same team. Nobody has a different rank. Okay? Even the captain still is just a player on the team. So yesterday, when we were talking about permutations, we used this notation of NPR. And the definition of n objects arranged where order matters, r at a time, was n factorial over just the n minus r factorial. I'd subtract that. So for example, if I had 7 permutate 3, it would be 7 factorial over 7 minus 3, that's 4 factorial. But today, in combinations, it's different. I use n factorial over the same n minus r, but at the end of it, I have to do another r factorial. So for example, if I want to do 7 combination 3, then I have 7 factorial over 7 minus 3, that's 4 factorial, but I also have another 3 factorial down there. Okay? Here's an example again. If I'm choosing 5 objects, 2 at a time, where order doesn't matter, it'd be 5 over 5 minus 2, which is 3, times 2, which is this number. Okay? And that's 10. All right. Here's another question. If the order is not important, how many different 7-card hands are possible? Now, if you don't know what playing cards are, they're like the cards that have the symbols on them. So, for example, you could have maybe the 4 of clubs, and there's 4 little clubs. There's a 4 here. They're playing cards, and sometimes they're red, sometimes they're black. They're cards, all right? Now, there are 52 cards in the deck. If the order is not important, that's the key word, how many different 7-card hands are possible? Now, first of all, you need to decide, is it a combination or is it a permutation? And the way that you tell is whether order matters, whether arranging these in a different order will change the look or the importance of the things you're trying to arrange. Now, in this case, it tells me right away order is not important, so we know it's a combination. Now, to do the combination, I put the giant C there. How many objects do I have to choose from? There are 52 objects to choose from. How many do I want to group at a time? 7. 52 choose 7 is 52 factorial divided by 52 minus 7 is 45 factorial, and then 7 factorial again. Now again, this would be kind of brutal to do by hand. 52 times 51 times 50 all the way down to 1. And down here I have 45 times 44 is 43 all the way down to 1 multiplied by 7 times 6 all the way down to 1. That's a lot of stuff to type in. But luckily your calculator will do this for you. So for example, I'm just going to clear this out. If I want 52 objects chosen 7 at a time, I would type 52 into my calculator. I'll go to Math, over to the Probability menu, and do NCR. That's the third option. And now I'm going to choose 7 at a time. How many options does that make? A whole lot. That's 133,784,560. That's a lot of different possibilities. 133 million, I think it's 784, 560. That is a lot of different hands. That means that you could do that 133 million times and never get the same hand twice. We're assuming that you shuffle every single time, but wow, that's insane. The next part, part B, how many of these cards all have the same suit? How many of these hands have 7 cards of the same suit? This requires you to know what suits are. There are 4 suits. There are clubs, and the club looks kind of like a clover, so it has 3 leaves, and it has a stem on it. So that's a club. All right, the spade is supposed to look like a shovel or a spade. And so it's a fancy shovel because it has an interesting point on it. It's sort of like an upside down heart with a stem on it. Okay, there's the spade. All right, then there is something called a heart, which you should all know about. I don't because I'm loveless. So there's the heart. Looks like that. And then finally, the last suit is a diamond. If you're unfamiliar with playing cards, I'll make sure to bring some to class so you can see a deck in person and understand how this works. Now there's 4 different suits. There are 52 cards in the deck. How many cards are there in each suit? If I divide 52 into 4 equal groups, there's 13 cards in the same suit. So for each suit, there are 13. There are 13 clubs, 13 spades, 13 hearts, and 13 diamonds. Now, if I want to choose 7 cards of the same suit, well, I have to do the different possibilities by the fundamental counting principle, and I'm going to just do OR. So that means that I'm going to maybe get 13 clubs. If I got 13 clubs, there would be 13 of them, and I want to choose 7 of them at a time. Now, does order matter? No, it doesn't. Order is not important. So I don't care what order I have the cards in. They're all are, as long as they're all spades, that's all I care about. They're all clubs. Excuse me. Then, if I want spades, I could have 13 spades, and I want all of them to be the same as well. Or I could have 13 hearts and choose 7 of those, or 13 diamonds and choose those. Now, obviously, it should be clear to you that I can't have clubs and spades and hearts and diamonds all at the same time. So I can either do one or the other, or the other, or the other. There's 4 different ones. So all I have to do now is take my 13C7 and write it down as the formula. 13 factorial over 13 minus 7 is 6 factorial. Then 7 factorial here. And all of these are going to be the same. It's the same idea, but with just different suits. And I can't do all of them at the same time, so that's why I'm plussing instead of multiplying, because they don't happen at the same time. I hope that makes sense. I can't get all of these at the same time, so it's not like the dinner problem. The dinner problem, I was choosing all of those items. I chose a dessert, an appetizer, an entree, everything else. I'm not choosing all the suits at once. I'm only doing one at a time, so I'll have to add. Now, again, instead of doing this by hand, I can use my calculator to assist me. I want 13 items chosen, 7 at a time. 13, choose 7. That's 1,716. I'm going to multiply that by 4. 7's 4 times. There are only 6,164 ways that can happen. Okay? From a group of 20 volunteers, you're choosing 18 to be, at least 18, excuse me. That's very important. I forgot to read that word. At least 18 to be peer counselors. And how many different ways can this be done? Now, first of all, is this a permutation or combination? You have to ask yourself, does the order matter in the choosing of counselors? Does it matter if I choose a different counselor first? It shouldn't, because all of them are still going to work together. So in this case, it's going to be a combination. Now, how many do I want? Well, it depends. At least 18. I could have 18, 19, or 20. So I could have 20 counselors, and I want to choose 18 of those. Or, and this again, I'm adding because it can't happen at the same time. I have 20, choose 19. Or I have 20, choose 20. Right? And so my answer will be 20 factorial over 2 factorial, 18 factorial, plus 20 factorial, that's a bad exclamation point, over 1 factorial, 19 factorial, or 20 factorial over 0 factorial, 20 factorial. Now it's important to note here, remember from yesterday, 0 factorial is 1. So that doesn't mean I'm going to have a 0 in the denominator. And in fact, I'm just going to use my calculator to do these quick. So I'm going to do 20. I'm going to do combination 18 at a time. 20 choose 18. It's 190 ways plus, in this case, 20 math combination. Choose 19 at a time. Only 20 ways. And the last one is only going to be 1. Now watch why that happens. If I have 20 factorial on the top and 20 factorial on the bottom, those will divide out to be 1. Now 0 factorial is 1. So 1 divided by 1 is going to be 1. So there are 211 ways for you to choose camp counselors if the order doesn't matter. Let's say a restaurant offers 6 salad toppings. On a deluxe salad, you can have up to 4 toppings. How many different combinations of topping can you have? All right, first question. Is this a permutation or is this a combination? Does the order matter when I'm assembling the salad? And this is a debated topic because some people would say yes, some people would say no. But I'm going to tell you for this class, if I'm having a salad, okay, and it's full of lettuce and other toppings, I don't ever just, put the salad on the bottom, then put the cheese on top of that, and then put the tomatoes on the top of that, and just eat it that way. In this class, we're going to mix up the salad. We're going to take the 2 salad spoons on the side here, and we're going to mix this bad boy up. And so in this case, it doesn't matter what order I have, because in this one, all the stuff is going to be mixed together, and when it's all said and done, I'm going to get a mixed salad. Okay, I don't like salads that are just stacked. Okay, so my mixed salad in this case is going to be all mixed up. So this is going to be a combination. They're all mixed up together. So I have 6 salad toppings. I want to have up to 4. Now look at the wording there. It says up to 4. Do I have to have 4 toppings? No. So there's options. I could have, out of the 6 toppings, I could choose no toppings at all. None. I could choose 1 topping. I could choose 2 toppings. I could choose 3 toppings, all the way up to 4 total toppings. So I could have 6 factorial over 6 factorial, 0 factorial, 6 factorial, 5 factorial, 1 factorial, and so on. I'm just going to keep writing these down. And of course, to get credit on your exam, you have to do this work that I'm doing right now. You have to show me all the different factorial notation situations you'd have to do here. Because if you didn't have a calculator, you'd have to do these by hand. And it is possible, especially with the smaller numbers here, for you to do that. But I'm going to use my calculator to assist me just for the sake of time. This one I know is going to be 1 for sure, because that's going to divide out to be 1, and 0 factorial is 1. This one is going to be 6, because 6 factorial. And then, if you don't believe me, I'll just do it for you, because I'm sure some of you are watching the video like, Loveless, I don't trust you. I don't think you're right. So 6, choose, combination. I want 1 at a time. It's 6. 6, math, combination, 2 at a time. I'm doing this one right now. It's 15. 6, choose 3 at a time. Okay, we'll do that one. 6. Oops. 6, choose. I think it's going to be 15 again. Oh, 20. I was wrong. This one for sure, though. You see how these ones are the same, the opposite order? So that's going to be 15 again. I'll add those all up. 15 and 15 is 30, plus 20 is 50, plus 6 is 56, plus 1 is 57. There are 57 different possible salads you could order. Now, on the very last page, I want you to summarize what we learned in this video. I want you to write what the difference between permutation and a combination is, and any questions you might have to ask in class tomorrow. Have a great weekend.